Hello everybody, my name is Jemmy, and today I'll be giving you a brief overview on generative adversarial networks, and I'll be demonstrating how it works. And yeah, the title of this video is Generative Adversarial Networks, but it's actually fun, so I'll try my best to make it fun. So what is Generative Adversarial Networks, or GAN? It's basically like an AI or neural network that will create an image that actually isn't an image, so it'll just make it by itself depending on real images you give it. So here's a good example of a generative adversarial network. So you have some real money, you have a counterfeit money or the generator, and then from then you have the cop, which is the discriminator, and you give real money and counterfeit money to the cop or the discriminator, and then they will check if it's true, if it's like a real money or is counterfeit money. If it's any of those, it will go back to the counterfeiter, and then it will update the algorithm accordingly. And if you want a more formal chart of a generative adversarial network, then what you have, this is right here. So you have the real images, you have the generator network, the fake images, which is fake images. This will create the fake images. They'll both go to the discriminator network, and it'll print out what it predicts. And and this is a picture of what I got after trying to do with Pokemons. It's not the greatest. I ran this with 1,000 epochs, which is basically how much times you want to like train your code, basically, or train your AI model. And it's not the greatest one. The one that I like the most is this one over here. It looks kind of like a Pokemon, kind of like Pikachu, but the rest is just a bunch of like colors. And I want to show you my code now. So this is my code, and I'm not going to run it again, but I'm just going to show you what it is. If you want to download the notebook, it's in the description. You might need to change some things like the path, but otherwise you should be okay.
I'm using the
Pokemon image API or something, and then I just downloaded the file. The link is also in the description if you want to try it out. You can see they give some good images of Pokemons, and then we use those images to make our own images, but it didn't turn out too good. You might need to do it with like other parameters. You might use different transforms. There might be better ones, but at the same time, this is what I got, and this is what I can do. So that was the best out of the lot. And I'll show you what the code does. So up here, the first one is pip install fastbook. We need fastbook to run all of this because it has some important features. And then after that, we import fastbook, and then we just import a bunch of other fastbook stuff, vision, GAN, and callback or whatever. And then after we install everything, we now create our data block, and our data block is this is the size of 128, 64, and then from then this is our transform we're going to be using. We're going to be using a resize method, and by the way, all this code is from AI Builders, and so I thought it was pretty interesting, so I decided to make a video about it. Their video is also in the description if you want to go watch that. And this is a bunch of other stuff that will create our data block or D block. And then here we're going to locate our images that we want to use. So we're going to mount our Google Drive first with this command right here. And then we're going to go to the path. We're going to set the path to our images. And the path to my images is content, Google Drive, my drive, and then Pokemon. My folder is called Pokemon. It's originally called something else. I don't remember, but make sure it's correct. I'm pretty sure you could go right here too, and then you could find your way to your drive from there. And then you can click right here and then click copy path and then paste it in here. But I just got it straight from Google Drive. So you could do both ways. This is probably easier because it's right there. But anyway, will work. And then now this will do something with our data block. And then from then we'll show a batch with 16 images of the real images we gave them. And from then we will create right here. This is to
one inconspicuous jump cut later.
And this right here is used to create the generator and the discriminator that we were talking about earlier. So the generator is creating the fake ones, and then the critic is basically the cop trying to see if it's fake or real. And then here it's an error, but it's usually not, because I restarted the runtime or something. So this one right here, learn, is basically to create the model, and then these two, this one is basically saying it's going to be only using train set, not validation set. And this one will run our code. Will basically run epochs. This is how much epoch is going to run. I did 1,000. It might overfit, but from experience, the more the better. So that's I ran 1,000 times, actually 999. But if we count the 0, then it would be the 1,000th time if I could go up. There you go, 0. So yeah, 1,000 times. And here show the result. I showed 500, but then I restarted the runtime, so it didn't show, obviously. And let's go back to this one, right? So this is the one I got after I ran 1,000 times. It doesn't look too great, but if you run like maybe 1,000, 10,000 times, maybe it will look better. Who knows? Hello everybody, I actually ran the code again, and if my voice is too loud, I'm sorry. I'm holding the microphone because of how actually kind of good this batch or this image we create is. It's not the best, but it's not bad either. I mean, okay, it might be a little bit on the negative side, but if we look at some of the Pokemon, I saw like really good ones. Let's move it to this side. Where is it? Oh, this guy. It's like very pixelated Pokemons. I think it's because the original image was kind of pixelated itself. You can see this looks like a Pokemon. Like this is the head, this is the arm, this is the legs. This also looks like a Pokemon. Like front, back leg, front leg, back leg, front leg, face. Right here, this is the mouth, this is the eyes, and then this is the horn. That looks like a Pokemon. This also looks like a Pokemon. This looks like Abra, like backwards. This looks like Sandslash. And you could see a bunch of like similarities because it does come from there. This looks like Clefairy, and that tail kind of reminds me of like, I forgot the name, but like something I forget. This one reminds me of like Dusclops, like the stature. And what else? This is like a Clefairy, I'm pretty sure. Sheldum is here. I'm pretty sure that reminds me of Sheldum. That looks also like Sandslash. Let's see, what else? I don't know why that kind of reminds me of Gengar. And is there any more that looks like something else? Oh, this reminds me of Gibble, or Gibble. That I don't remember their name. And we could try running it again to get a different result. This one might be better, it might be worse, who knows. We have to run it out and see. Sometimes it takes a long time, but most of the time it's pretty quick, like 10 seconds. 10. Okay, never mind. It might take a little bit longer. There you go. So here is the new set. Again, it's like kind of like a dice roll. It might be worse, it might be better. This kind of looks like Larvitar. Not really though. Looks like shiny, how do you call it? Shiny Muck, I think. Muck is his name. Yeah, these are all rainbow for some reason. I don't know why. Let's see. What else looks like? This looks like, it's like the flying Pokemon with like the clouds on it, and then there's like blue. It's like a bird. I'm not sure what that name was, but there's something. It's like Spoink. This is like Pikachu. That looks like Pikachu. But anyways, that is basically it. You can change the value here to display more or less Pokemon. I put it to 500. That's why it's 500 right here. And if you increase it, I think the chances of finding a better Pokemon actually increases. But again, if you don't increase it, just like 500, it won't differ that much. But keep in mind, the more you increase it, the more laggy it gets. So yeah, that is it for today's video. I hope you enjoyed, and see you in the next one. Also, thank you to AI Builders for this code. Bye!